Hello and welcome to this episode of Math with Martinez. We are in our unit on absolute value functions, equations, and inequalities, and we are continuing to look at this very first skill where we are graphing absolute value functions and analyzing their key attributes. So we've already kind of gotten a preview here of what the parent function looks like. Now let's look at graphing some more absolute value functions. You're going to need a handy dandy graphing calculator to do this, and I have my digital one here. And you're going to want to go ahead and go to the graphing option, which is to click this y equals button in the top left hand corner. So let's go ahead and graph this very first example. How do we do that on our calculator, you ask? Well, let me show you. To get an absolute value, you're going to want to click the math button. It's below that green button. And then you're going to want to go arrow over so that at the top you're highlighting the abbreviation for number. And that very first option is ABS. That's not to give you a six pack. That is ABS as in absolute value. So if you click enter, now you have an absolute value set of grouping symbols. And then we'll go ahead and inside we'll type X, and you need to use the X that's next to the alpha button. That's the variable button. And the rest of our function is plus 6. Once you've got that, press enter. And now we have our function ready to graph in blue in our graphing calculator. And to see the graph, you click the graph button, which is at the top right-hand side. And your window will look something like this. You'll see it does have that shape of a V, like we said all absolute value functions would, but this function, a little different from the parent function, has been shifted over. You can see that it's been shifted over to the left. How many? Well, let's look at our table to see just exactly what happened. To select table, you're going to need to press the blue button second and click graph again. Okay, now what we are looking for here on our table is a place where it seems like our countdown changes positions, right? So I'm looking, and at the top here, it's like 8, 7, 6, 5, 4, 3, 2, 1, 0, 1, 2, 3, oh. Do you guys see how it kind of like turns around like that? So I'm going to pick points around where the turnaround happens. And what is that turnaround called? That turnaround, that turning point is called our vertex. So I'm going to pick a couple values on either side of the vertex, and that's what I've done here in my table. The vertex of this graph is at the x value of -6, and the corresponding y value is 0. And then the values that are just on either side of that I just transferred from my calculator over. Now I've got a nice little table that I can see the values. I can plot those values like I've done here, and then create that nice V shape. So that's pretty cool. I love using the technology that we have in order to be able to do this. And it's important that you can use technology in order to do it. It's actually one of your learning goals as an Algebra 2 student to be able to graph using technology. So now that we've got that, let's answer the question, the domain and the range. Like I showed you in our previous video, we want to highlight the section of the X and Y axis that corresponds with where our graph occurs. So we read for domain, oops, let me go back one page. For domain, we read from left to right. So we're going to highlight from left to right wherever our graph is happening. Okay, so starting on the left side, well, yeah, I'm noticing the arrow keeps going out. So I'm going to highlight all the way over, and my arrow does keep going up and out on this side forever. Even though my window is only that big, I know it keeps going beyond that. And so I'm highlighting that entire X axis, which means, ladies and gentlemen, that the domain for this function is all real numbers, or as we can write in interval notation, -infinity to infinity. Now, what about the range? Let's highlight that in blue. Where we want to shade from bottom to top on our y-axis, range is y values. So on our y-axis, where's the bottom of this graph? Well, right here at 0, and then it keeps going up. That's where the graph occurs. The lowest my graph goes is 0 all the way up. And so how do we write that using interval notation? The lowest this goes is 0, and then it keeps going up to infinity. Infinity will put a parenthesis as our boundary indicator. It can't actually touch infinity, so we put an open boundary like that, but it is actually touching 0, so I'm going to include that using a bracket symbol. There, we've got it. We have identified domain and range and used technology to graph. Let's look at example number 2. We want to grab that graphing calculator again, and you probably left it off right here looking at the table. So click y equals to go on back, and we can go ahead and clear that first graph by going up to it and clicking the clear button. That clear button is right below the little navigation left, right, up, down. All right, now let's type it on in. We want to get our absolute value symbol, so we click on the math button below alpha, go over to number, select enter. We want to type in x minus 1. Make sure you use the minus symbol, it's above the plus. All those operators are next to each other: divide, multiply, subtract, and add. And then outside, so I'm going to use my arrow key to go on out, I'm going to add 2. Go ahead and click enter, and let's look at our graph. Okay, so it still looks like a V, but it has changed a little bit. Let's look at our table. To see the table, you press the blue button, second, and graph once again, and let's look for that turnaround point. Let's look for where our countdown changes positions. So I'm going to come up here, 9, 8, 7, 6, 5, 4, 3, 2, 3, 4. Oh, there's the turnaround. The turnaround happens right here at the point 1, 2. At the point 1, 2. So that must be my vertex. I'm going to kind of put that in the center here at the point 1, 2. And then I'll get the points that are kind of around that. And that's what I've got here on this table. I've used those points to graph on my little graph there. And I've highlighted this. I'm going to just call them V for vertex. That's where the vertex is. I'm highlighting that. So once you've got your graph sketched out now, let's go ahead and look at the domain and the range. We read domain from left to right. This graph keeps going out to the left forever. It keeps going to the right forever. So once again, we have a domain of all real numbers, negative infinity to infinity. Now let's look at our range. Where's the bottom of this graph? Where's the lowest that this graph goes? Go on your y-axis and go, where's the very lowest it goes? Right here, and then it keeps going up from there. Keeps going up from there. So what is that height? That is a height of 2. So the lowest it goes is 2. That's our bottom, all the way up to infinity. We are actually touching 2. We want to include it, so we'll use a bracket. But for the upper boundary, infinity, we can't actually get to infinity, so we'll use a parenthesis bracket. Or I should say an open parenthesis. All right, ladies and gentlemen, we're halfway through. Let's look at these next two. Again, we want to use our handy dandy technology. Go to y equals. If you don't want to clear it all out, you can just use your backspace button using this little delete key, which is right below zoom. And then we can just kind of go in and edit. What do we want? We want to have at the front here a 3. And then it's an x minus not 1, but minus press delete, 4. 3, absolute value of x minus 4. All right, let's look at our graph. Okay, we've got a V shape, but it's shifted over a little bit, and I'm noticing here that it is a bit more narrow. Let's look at our table. Blue button, graph. Okay, let's look for our turnaround. Let's look at our turnaround. At the top here, I'm noticing it's at 24, 21, 18, 15, 12, 9, 6, 3, 0, 3. Oh, there's the turnaround. The turnaround is at 4, 0. The turnaround is at 4, 0. And then there's some points around that. This graph is narrower because of this 3 in the front. That's why it's got this shape where instead of just increasing here each time by 1, we're increasing by multiples of 3. Okay, so we've got our vertex marked and highlighted. Now let's go ahead and find our domain and range. Domain in green, horizontal. I'm noticing it starts here and goes out to the left forever and to the right, going out forever. Those arms are going left and right forever. So once again, this is a domain of all real numbers, negative infinity to infinity. And the range. The range. How low does this graph go? What's the lowest this graph goes? Starts at 0, goes up to infinity. So starts at 0, goes up to infinity. It actually touches 0, so we'll use a closed bracket to indicate we're including that point, but we can't actually include infinity. So we'll use a parenthesis. All right, now this last function, you can see I've already graphed it here. It looks a little bit different, but let's go. And guys, please practice this on your graphing calculator. Make sure you know how to do this. It is like anything else. If you want to get good at those keystrokes and being able to do it quickly, you do have to practice it. Just like on any video game or something, you have to kind of train your fingers to have that muscle memory. So let's do that now. Let's go to the y equals. Let's clear this out and type that function in. It is a negative. So you need to use the negative key, which is next to the period at the bottom of your calculator. It is a negative and then absolute value. Click your math button, arrow to the right, and it is that first option. Press enter. 2x, and then use your arrow key to go on out and press plus 7. When we go ahead and graph that, we'll notice that this graph is opening down. And let's look at our table by pressing second graph and look for our turning point. Where's that turning point going to be? Oh yeah, look at there. 1, 3, 5, 7, 5, 3, 1. This is different. It's counting down and then counting up. Interesting. But that turn happens here at 0, 7. Do you see? It goes 1, 3, 5, 7, and then it turns and starts going down. 5, 3, 1. So that's our turning point. Our turning point is 0, 7. That is the vertex. And then I've got some points from my table that I copied on either side, and I plotted them as well. Now let's talk about our domain. Y'all, what is the domain for this function? Well, I notice here it starts at 0 and goes to the right and to the left forever. So this is all real numbers, negative infinity to infinity. And what about the range? What is the range for this function? A little different here, little different. The bottom of this graph, where's the bottom? Well, it actually doesn't bottom out anywhere. It keeps going down forever. What we have instead this time is a maximum value of 7. So the bottom of this graph, it keeps going down, 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 down forever, which means the bottom of this graph is approaching negative infinity. It keeps going up all the way to 7. It actually touches 7, so we're going to put a bracket around that to include that boundary, but we cannot touch negative infinity. So we'll put a parenthesis there. Ladies and gents, that is graphing absolute value functions using technology to do so, and finding domain and range, which are some key attributes. Not only domain and range, but we were also able to find that vertex, that turning point of our graph. Ladies and gents, if you have questions about this video, about these exercises that we did, please take a moment and share those now. And until next time, stay fired up.